All right, lesson 1. I can understand what it means for a number to be raised to a power and how to represent the repeated multiplication symbolically. That's just a bunch of fancy words that mean today we're going to use exponents. So when you learn how to multiply, your teacher probably taught you that multiplication is repeated addition. So instead of having to write out 3 plus 3 plus 3 plus 3 plus 3 plus 3, you can multiply 5 times 3 because you're adding 5 sets of 3. The same concept applies to exponents, except now we're multiplying 5 sets of 3. So what this looks like is 3 to the 5th power. It's a big 3 and a smaller 5 up in the top right-hand corner. This is the base. You're going to hear me refer to that as a base. This is your exponent. And it's pronounced 3 to the 5th power. All right, so 5 to the 6th power means we've multiplied 5 6 times. And 9 sevenths raised to the 4th means we've multiplied 9 sevenths 4 times. When you write a fraction with an exponent, make sure that your fraction is in parentheses. Otherwise, you had 9 sevenths, forgot your parentheses. This is now saying only that 9 is being raised to the 4th power, not the 7. But the 7 needs to also be raised to the 4th power. So if you put parentheses around it, now you're multiplying 9 sevenths 4 times. So you need parentheses for fractions and negative numbers. So let's work through some examples. I also need to tell you that when everything is multiplied out, when you've done all of that work, this is known as standard form. I've multiplied 5. 5 is my base. 1, 2, 3, 4, 5, 6 times. So 5 to the 6th power. When you have written with a base and an exponent, this has now become exponential form. So later you may be asked to write something in standard form or exponential form. Example 2. I've multiplied 9 sevenths. So 9 sevenths is my base. Remember what I said about fractions and parentheses. I've multiplied 9 sevenths 4 times. So my answer in exponential form is 9 sevenths to the 4th power. In example 3, they've given us exponential form. We need to write it in standard form. So I've multiplied negative 4 elevenths 3 times. That means that I multiply negative 4 elevenths 3 times. Example 4, my base is negative 2. I multiply that 6 times. Our last example is a decimal, 3 8/10. It's being raised to the 4th power. You don't have to put parentheses for the decimals. We are multiplying 3 8/10 4 times. So that is standard and exponential form. Anytime a number is raised to a power, it's raised to that power, the nth power. So if I had a base of 8 and an exponent of 6, that is, you would say that is 8 to the 6th power, 9 to the 12th power, x to the 10th power, x to the nth power. Even though we don't know what those letters stand for, we can still say that we know what the base is, we know what the exponent is, so we know that the base will be multiplied that many times, even though we don't know how many specifically that is. X to the second is called squared, so sometimes you may see me write 3x to the second. I'll say 3x squared. It's the same thing. Over here, x to the third is pronounced cubed, so x cubed. You can pause here and do exercises 1 through 10, and then I will go over the answers. So in exercise 1, you are multiplying 4 7 times. So I know that my base is 4, my exponent is 7. That's 4 to the 7th power. Exercise 2, 3 6/10 to the 47th power. I look at my exponent. I know that I've multiplied 3 6/10 47 times. Exercise 3, -11 63/100 has been multiplied 34 times. So I have -11 63/100 to the 34th power. Don't forget your parentheses because that's a negative number. 12 to the 15th power means I've multiplied 12 15 times. Exercise 5, -5 to the 10th power. Don't forget your parentheses because that's a negative number. Exercise 6, 7/2 to the 21st power. It's a fraction, so don't forget your parentheses. Exercise 7 is -13 to the 6th power. Parentheses because it's a negative number. Exercise 8 would be -1/14 to the 10th power. Parentheses because you have both a negative number and a fraction. Exercise 9. I told you don't let the letters confuse you. You still know that this is x to the 185th power. And you know if x is raised to the nth power, then it is being multiplied n times. All right, you learned back in elementary school somewhere the difference between even and odd numbers. So 5 would be an odd number. 6 would be even. If I multiply out -3 times -3 times -3 times -3 times -3, we know that two negatives multiplied together result in a positive, right? So if I multiply these two negatives together, I would end up with a positive result. I'm not worried about knowing the answer right now. I just want to know whether I'm going to get a positive or a negative answer. So those two negatives make a positive. These two negatives make a positive, and I'm left with one negative. A positive times a positive times a negative would leave us with a negative result. Whereas over here, I've multiplied this -2 by an even number. So -2 times -2 . Now I can mark out my first set of negatives that become positive. Those two become positive. Those two become positive. Positive times a positive times a positive will give me a positive result. So now we know that when a negative number, only the negative numbers, is raised to an odd power, then the result is negative, because you're left with one negative multiplied by all the positives that you were able to cancel. But when that negative number is raised to an even power, the result is positive, because you've canceled out all your negative numbers. So -4 raised to the 4th power would give you a positive result. -7 raised to the 3rd power would give you a negative result. Negative because the exponent's odd, positive because the exponent is even. Exercise 11, you could pause here and try those. If we are multiplying -1 12 times, 12 is an even number, and we said that even exponents will give us a positive result. And here we have 13. 13 is an odd number, so our result will be negative. So this is asking, is it necessary to do all the calculations to determine the sign of the product? No, it is not, because we know the rule of negative times a negative makes a positive. So we know that every time there's an even amount of exponent, an even amount of numbers being multiplied together, all of those negatives are going to cancel, giving you a positive result. If you have an odd amount, then you'll have a negative left over that turns your entire result negative. So 95 is my exponent. That means that my result will be negative, because 95 is an odd number. 122 is an even number, so our result will be positive. So here's the rule. If n is a positive even number, then -55 raised to the nth power is positive. Even, positive, odd, negative. So if n is a positive odd number, then this result will be negative. All right, last exercise. Josie says that -15 to the 6th, -15 multiplied 6 times is -15 to the 6th. Is she correct, and how do you know? Take a minute to answer that question. Okay, Josie is right that -15 multiplied 6 times would give you a base of -15 and 6. She just forgot something I've said about 10 times during this lesson. You need a parentheses for negative numbers and fractions. So if she were to put parentheses around that -15, that would make that correct. All right, so that is today's lesson. Watch it as many times as you need to.